Hi, for this video what I want to do is show you how to verify a trig identity. And with these, a lot of times there are multiple ways that you can do this. Basically, your goal with verifying the identity is to try to either show that the left side equals the right side, or that both sides can be simplified down into the same thing. In this case, what I'm going to choose to do is I'm going to choose to work with secant squared x minus the cosecant squared x side and try to get it equal to tangent squared x minus cotangent squared x. For this one, I am going to use two of the Pythagorean identities. I do have a video that shows how to come up with those, but the Pythagorean identities tell us that secant squared x is equal to tangent squared x plus 1, and we also have a Pythagorean identity that cosecant squared x is equal to cotangent squared x plus 1. So I'm going to use both of these trig identities because of the fact that I'm trying to go from secant down to tangent. There are other ways I'm sure that you could get to the same thing, but this was the easiest way that I saw. So what I'm going to do is I'm going to replace secant squared x with what it's equal to. So we know that secant squared x is tangent squared x plus 1. And then we're just going to subtract cosecant squared x, and cosecant squared x is equal to cotangent squared x plus 1. And this, if I simplify, so I'm taking this becomes here. Okay, if I simplify this, all I have to do is I have to distribute in my negative into the second one. So I'm left with tangent squared x plus 1 minus cotangent squared x minus 1. And if you notice, my 1's end up canceling out, so 1 minus 1 is 0. So I'm left with tangent squared x minus cotangent squared x. And I have shown that secant squared x, when I start with this side, it does end up being the other side once I simplify. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know that as well.